Hey everyone, we got a new job here and I thought we could do it together. It's a transom extension job. We have a scan of the transom of the boat. It's a South African boat, an Ace craft. And we also have a scan of the current metal extension bar that he's using. So just started on this design job. We have to make a CNC-cut kit, like a temporary mold, for the boat builders to create the transom extension with. So we've got 2 scans and definitely going to need some feedback from the boat builder. But I thought we could just start by getting the scans set up and aligned. So I'll make my image a bit smaller. I just figured out how to do that. There we go. Maybe you don't need to see me at all. I don't know, I'll go really small. Maybe I'll just disappear altogether. There we go. How about over here? Yeah, okay, so let's get into it. Right, so the scans just come in. It's, is it aligned? It's not aligned in any direction. So what we're going to do first is my old 3-point alignment trick. Now I have a video just on this, but I'll go through it with you. So we go drafting tab, we get these annotation dots, and we find what we think are 3 flat areas on the scan, snapping to vertex. Then we select the whole thing, and look, I normally type this kind of thing in, but let me see if I can find it in the help menu, and we'll also get the help happening over here dynamically so you can see what command I'm using. There we go. Right, so I'm pretty sure it's in the transform, and it's orient objects on surface. It's this one, orient 3-point, right click. So orient 3-point, and we want to snap to points. Points, there we go. 1, 2, 3. Now we'll go into front view. Well, look, it's the back of the boat. I normally like to align things, you know, front to front, back to back, but we'll, because this is the whole job, we'll go front view. So now you select the project. This means we're projecting those 3 points onto the construction plane. So 1, target point 2, I think it should be over here. This will make sense in a minute, and target point 3 there. Okay, now hopefully that back plane, the computer's just processing for a second. Hopefully that back plane is going to be completely flat to the back of the transom. The fact that it's rotated at that weird angle is no big deal, because we can do a gumball rotation. Well, it's still processing, just processing that movement. And while that's happening, we can't do anything, just gotta wait. I'm gonna pause. Okay, we're good. So that's taken place, and now what we're gonna do is we'll use the rotate command, rotate 2D. Select the object to rotate. We'll click on the mesh. Okay, we've got selection filters. There we go. So we'll click on the mesh, and well, actually we'll box select everything. Rotate 2D. Select objects to rotate, press enter. Okay, I'm going to press spacebar because I'm a rebel. Alright, and pick 1 point there and 1 point there. And now I'm going to rotate it around. I'm going to press the tab key and snap to straight plane. Okay, so now we have the back of the boat looking close to how we want it to be. Just let the computer think for a second. I think okay, so we'll select all this again, and I'm gonna get the move tool, and I'm gonna click on that point there, and I'm gonna type in 0, 0, 0. Press enter, and now that scan has moved to the origin point of the file. Okay, so that's been moved, and now we have a look in top view, and we can see it's relatively straight. Front view looks as though I might have gotten it the wrong way around, so that's fine though, because most importantly it's flat. So I'll select everything and gumball 180 degrees. Just let the computer do that. Now, why is the computer taking so long to perform these operations? It's because the mesh is quite large and it has a lot of vertices and mesh wires to move every time. So let's take a look at this. So how do we assess how large the mesh is? We click on the mesh and run the command reduce mesh. Look, even if you're not going to reduce the mesh, this is a great tool because it tells you how many polygons are in your mesh. And as you can see, there are 5,606,865 polygons. Now, that's a lot. So every time we move it, my computer is moving 5.5 million points of data. So that's a lot. Look, a scan like this, really, it could be under 1 million. So we're going to click on reduce by percentage, and I'm going to write in 75%. Maybe we'll even go 80%. 1.1 million. The only problem is this is going to process for a while, but I'm going to hit OK, and then I might just pause the video while that processes. Hey, just checking in, unpausing the video, we're at 16%. So we'll keep going. You can see up here in the top left corner, it gives you a percentage bar. When that reaches 100%, well, it isn't over because it tends to take another minute or two. There is another program. There are other programs you can use to reduce the mesh, but that are quicker. But Rhino does a good job, and it just takes a bit longer. So we're at 85%, and I got a bit cold while we were waiting, but I thought perhaps we could just review this together, which is basically the Rhino help file. This is the option we did, reduce by percent, specifies a reduction by a percentage of the starting polygon count. Locked mesh points. Reduce mesh lets you lock mesh points. Reduction will not alter those points. Oh, I didn't know that. So you can actually add points that you don't want to be reduced. Well, that's pretty interesting. We should have a play around with that. Oh, and there's accuracy. Oh, this is very interesting. To access hidden command line options, type a hyphen in front of the command line. Well, isn't that interesting? Well, it's done. You can see it's highlighted yellow. That means the mesh reduction is complete. I'll click off. Now, if we run the command again, you can see we're 1 million points, which is a fair bit better. Now, I'm curious about that. So, reduce mesh, and then what do? We do a hyphen. Oh, it tells us over here. Reduce mesh. Okay, so now we type a hyphen in front of the command. Oh no, in front of, like, before the command. Okay. Sorry, I'm being a bit of a beginner here. Okay, hang on. Oh no, I've nudged the mesh. Uh-oh. I do this for a living, don't worry. Okay, reduce mesh. Oh, okay, look, so now we've got mesh reduction options, accuracy 10. So we're on accuracy 10, involves more calculations and is therefore slower. So what if we just go to 1? And we can undo this, but let's choose, okay. Right, now I'll press enter again, preparing mesh reduction. Okay, well that count's going a lot faster. But I don't know what, oh, reduction percentage 0. Oh wow, isn't this interesting? Sorry, this is not very good content, is it? But at least we're learning something together. At least I'm learning something. That's what I love about Rhino. There's so many commands. There's commands under commands under commands. Alright, we're at 100. And let's just run the command again, and so I run the command to see what our, oh geez, we're at 224,274 points. Well, I'm a little bit nervous that we might have reduced the mesh too much, so what you can do in this instance is press Ctrl Z and visually see if there's any big changes. Okay, that's before. After, no changes. I think we're fine. Now if we zoom in on the mesh itself, we can see we've somewhat pixelated it, but I'm thinking now we can just whiz the thing around with barely any calculation time. So I'm going to press Ctrl Z, Ctrl Z, Ctrl Z, Ctrl Z, and again. And look, I might just undo that last reduce mesh because I don't want it to be too much reduced, and I prefer the look of that. Okay, so we'll run the command reduce mesh one more time. And we're at 224,000, which is, yeah, it's reasonable. Look, I think that would be okay for this job. Okay, so now we do the process of straightening up. So in this view it looks okay. What I sometimes do is I make a new layer and I make that layer red. And while we're on layers, we should really make this layer 1, we should call it 0 scan. There we go, and this layer can be 1 lines. But now, for want of a better term, we can lock 0 scan when we need to, which I just locked it. Right, and now I'm going to draw a line which is orthographic across the screen in the Y direction with no deviation in the Z direction. So it's a straight line, for want of a better term, and it's really important that we try and set the job up aligned with the X, Y, and Z plane, so that when we're extruding things, we're consistent with the geometry. So you can see from this line, looking at the line, I'm using the line to assess the straightness of this transom rebate here. Now you have to remember this was a handmade or hand-modified boat, most likely. So you have to start using your judgment. Not everything's going to be perfectly straight. I mean, for example, you look at the angle of this here against the angle of that there, I can see they're different, but that's where a bit of human judgment comes in. Maybe we can assess these two as well. So if we go to, like, I don't know, the bottom of that rad there, come straight across. I'm holding down the shift key and I'm going to press tab, which means that I can let go, and now this line is constrained along the X direction. And look, that looks like it's in about the same spot. That's pretty good. So in front view we're good. So now I'm going to go top view. Right, and the same question, how straight along the X-axis is our mesh? So I can use the same line and find the line that I want to assess against, which I'm going to use this bottom chine. And I'm just moving along. It's really a decision-making process that the CAD operator has to do. You know, it's something you got to decide. It's a decision that you have to make. A lot of people think that reverse engineering is like automatic. It's not. It's a chain of decisions, and each decision leads to another decision, and that's like the foundation. So I'm just aligning the C-plane to this back point here. So each decision is the foundation of your later CAD work, which you can have a shaky foundation. Like I had a job recently where it had a twisted center line, and I aligned it somewhat offset, and we completed the job, but it caused a lot of unwarranted issues had I spent more time simply setting up the scan. Right, so I've just drawn a line across there, and this line I want to see it, so I'm pulling it that way. Okay, now I can see it, and typing in C-plane, I'm going to align my C-plane to, turning off project, align my C-plane to there. So now, when I draw another line, it's not going to be behind the mesh, because I want to kind of mark a center line. So we've got a circle here, so I'm going to draw a 3-point circle. Wow, I don't think that's very good. I'll draw another one. I mean, we don't have a lot of data to go on, but again, this is where the judgment comes in. This is where the art of reverse engineering comes in. We got a strip here, which is a keel strip. We can draw a line straight up there. I'm holding shift, so that line is perfectly aligned along the Z-axis. Okay, now these guys, I'm going to use the concentric align centers, and I'm going to pop them on that line. And I'm just thinking I'm using my arrow keys with a 0.1 increment and the nudge activated, which I'll show you how to activate nudge because it's super helpful. So it's in modeling aids, nudge, and you can have your arrow keys set to these increments. So see, I've got control and an arrow key is 0.1. Now this can also be a problem because you can accidentally move things, but you know, it's a cool tool. It's a great tool. So now what I'm curious about is I want to draw a line from here along the bottom of the hull to here. Now I'm going to mirror this, and hopefully they're about the same. And if they are, it's going to make, I'm going to turn off vertex snap, and I'm going to snap to this line. There we go. Alright, look, we've got a bit of a misalignment there. So does this mean that my center line is out, or does the boat have a bit of an unusual shape on it? And that's kind of what we're going to look at. So I'm going to go to drafting, and I'm going to take a measurement from here to where I think the actual end of the transom is, 4.89 millimeters. Now look, that's probably, look, whereas on this one we're perfectly aligned. So that's telling me that something on this model, well, it's not a model, it's a real life object, something on this real life object is not straight. And to be honest, in the real world, when you're dealing with scan data, you're dealing with real world objects, and the challenge is you're trying to draw CAD on them, which objects in the real world are naturally going to be bent out of shape by physical forces, whereas in CAD everything wants to be perfect. And that again is the game of reverse engineering. It's trying to align those two, and then if you have a physical output, which typically reverse engineering will have a physical output, the challenge is trying to make your physical output. The challenge is like weaving between the digital and the perfection of the digital and the imperfection of the scan, which represents the real world, and trying to shoot a line through the middle. It's a constant decision-making process. So what do we do here? Well, I'm wondering, look, sure, we're pretty straight along here, but I'm wondering if we should rotate the hull a touch so that these are more aligned, because at the end of the day we're going to be making a pod that goes on the back here. So what I can do is I'll find another line that I can check out, which I think will do a 3-point arc along here. It could be that my center line is out too, it's hard to say at this stage. So this is the investigation phase. So I've got a line here, click on the line, and I'm going to mirror it. I'm going to use this here. Okay, well, yeah, so it's slightly further over. Oh no, we're about the same. Okay, let's check some measurements. Let's go a measurement from here to this bottom corner. 637.75. And we'll go from here to this bottom corner. 632. Right, now that's pretty interesting. So we're plus 5 mil there. Okay, so let's go from here to here. 1150, and we'll do the same. We'll go from here to here. 1153. Okay, so this is interesting because we have a higher number here and a higher number here, which indicates a bit of a twist. So that said, these planing strakes, I think they aren't really something that we should be making critical measurements of. So we'll go again. We'll go from our perceived center line to this bottom corner, 999. Okay, and we'll go from this perceived center line to this bottom corner, 995. Okay, so I'm going to bring up some text. I like doing this. I've got two monitors, so sometimes the pop-ups go into the other monitor. Alright, and I'm going to put a +5 here. Right, now this text, we use it to mark, so +5, we'll just round up. Right, so we're +5 here, and now we'll come down here, we are +4 here. So this one is 4 higher than that one's about 5 higher than that one, so well, that's indicating a twist, which is, to be honest, typical for a boat. Now I have to build a transom extension kit. I don't want to build an asymmetric kit. So what do I do? Is my center line, look, my center line is plumb. I'm thinking this is indicating that the boat I don't have the boat set up completely plumb. Or even if this line is, this is a line that's straight along X, so I guess there is a bit of a gap there, but it's touching there. It's touching, it's pretty consistent. Okay, I think I'm going to rotate the, what happens if I rotate in this direction? And this is the crayon plugin, which I think the new Rhino 9 whip work in progress actually has this as a feature. I could be wrong, but then again, this plugin is $20, and it's just fantastic. It works with Grasshopper too. I haven't really. I don't know why it's disappearing. It's not working for me, but it's a good plugin normally. Let's have a look. Arrays, brush size, draw lines. I use it all the time, believe it or not, for client markups and whatnot. Don't know why it's projection, view, toggle display. I don't know why it's not working. Okay, well, all right, so +5, +4, which indicates that. So we've got some decisions to make. So we've got a center line, a perceived center line. I mean, yeah, it doesn't quite look right, does it? Let's just double check that this line is in fact heading straight up plumb. So I'm going to click the ortho. Yep, that's a straight line. And this, let's just double check that this line is also pretty good. So it's in ortho. Yeah, I mean, that's good. So the issue is here, we use this to set up initially, whereas clearly we have a gap here and we have a high number here, so I'm thinking we might just rotate this mesh. So instead of clicking on the mesh, I'm going to type in cell mesh. Cell mesh. Ah, I see. Okay, so we've got a locked layer. There we go. Cell mesh. Okay, and we'll group it. Okay, and let's, so we want to split the difference here. So what does 0.1 of a degree look like? That brought us a bit closer. Yeah. Okay, so 0.1 of a degree. Let's just redo this measurement. From here, our center line to, let's say, well, it's hard to say, isn't it, there? 639. 634. Look, I should really take it from the vertical face. There we go. 638. And we'll call it there 642. 638 and 642. Yeah, we'll delete those two. Oops. I'll delete the center line. 642. 637. Take another one. Call it there. 638. This is what scan data's like, you know, it's ambiguous. It's like 642. Okay, so 638, 642. Right, we'll get rid of these dimensions. I think we'll go for this outer chime one again. We'll go to, can you tell that there about the radius point? 994. Let's do this side. 999. Okay, so we're still +5 and we're still 9, 10, 1, 2, still +4. So that rotation didn't really change anything. Well, it did, but barely any. But what it's done is it's reduced our gap size down here. So you see, we used to have a 4.89. We'll get the drafting tool, we'll get a dimension from here to here, 3.31. Okay, let's have a look at this one. 3.28. Look, I know they were, this is like, it is precise, but at the same time you're going on feel. But this is just the initial setup. I want to reiterate that we're going to do more setup. So we'll take a look at this in side view now, and obviously it's heading downhill a little bit, so we'll sort that out too. So I'm just going to select the mesh and run the rotate 2D command. Rotate from here to here and do an ortho snap shift. There we go. Okay, back to front view. Now, because we're looking at it on a plane, it's basically the same, but we might just redo some of our measurements. So I'm going to type in cell dim, select dimensions, delete. And we'll get rid of that +4. We'll delete one of these lines, and using the align toolbar, bring the other one down to say about here. Visually inspect that line. Okay, still looking okay. This one, yep. Okay, and let's do a couple of measurements again. Go from okay, we still got a plus 4.5 to 5 on the right hand side. Just come straight along here to the furthest point out on 002, straight along here to the furthest point out 997 8912. So yeah, we're still plus 4 down here, plus 5 up there. Okay, and let's just have a look at our shape of our V. Okay, we'll mirror this off our selected center line. Okay, so that tells me the center line could potentially move over a touch. Control and arrow key. There we go. Mirror. Okay, what's our distance here? Drafting 1.73, 0.1, so we're about a millimeter out of alignment. We're more down here. Okay, so now sometimes at this point as an extra check, I'm still just making my mind up about this, about the orientation of the scan. Sometimes what I do is I select the scan, I copy it in place, I take one of the scans and I change the color. I change it to, like, I don't know, red. Okay, and then what I do, now they're both overlaid over each other. So then what I do is I grab one and I mirror it along the center line. And then I just have a look-see, see what I can see. Okay, did we change them both to red? No. Okay, so in the act of mirroring it, somehow we took it forward, so I'm just going to move it a little bit. Alright, so this becomes quite interesting. So you can see these are reasonably well aligned, and if we look over here, you can see this is pretty well aligned. Well, that's a bit further over there. How are we looking over here? Okay, what I'm going to do, what I sometimes do at this stage, is I make a new floating viewport. There we go. And what I do is I pan over to the opposite side to where I'm looking. Select everything, and again we're just making, look, they look pretty even to me. So I think that I'm gonna have to say that I have this scan aligned enough to start work. I'm gonna delete the red one, which is the one we mirrored. In fact, I'm not even gonna delete it. I'm gonna Control Z just to be extra careful to before I mirrored it, and to before I duplicated it. There we go. So now we're back to just one scan. So there's no chance that I accidentally mirrored the wrong scan, and now I'm working off a mirrored scan. I know I'm working off the correct scan. Okay, and at this point I'm going to, for this job, for the overall tolerance of this job, I'm gonna say that I think at this stage I'm going to say that we are good. The only question mark I have in mind at the moment is how we are on our setup on the side. I'm not entirely sure having this bottom plane come straight out like this is the correct orientation. So I'm gonna keep that in mind as I move forward. And I think what we'll do now is we'll bring in the next piece of the puzzle, because at the end of the day the thing we're building is relative to this, so it's okay. So I'll bring in the next piece of the puzzle. I'm going to delete the curves, delete the dimensions. I'm going to incrementally save the file, and the file size is going to be reduced quite a bit because we've reduced the mesh. And then we're going to bring in our next mesh, so we're down to 60 megabytes. So here we go, import. Yikes. Come back to here, Acecraft, Transom pod, there we go, 44 megabytes, so it's not a huge scan. And I remember this scan, it was a stainless steel part, and we just needed the two angles. So the angle that it bolts onto the transom with, and the angle that it mounts the motor at. So I believe this is the base and this is the engine mounting angle. So first up, this is really not a representation of a shape, it's more a representation of two angles. Well, I mean, of course it is a representation of a shape, but we're really using it for the angles that it represents, which are this one and this one. So what I'm going to do is select all that, and I'll group it up. I'm going to select these and I'll delete them. Now we're going to orient, I think we should orient this, so this needs to be up in the Z direction. So I think what we should do first of all is just get this onto the transom. So what I'll do is same as usual, and I do have a link to a video where I go into some depth about this technique, but I'm going to pop I'm going to cell dot, delete the dots, and I'm going to pick 3 points for my annotation dots. I'm going to select this, orient 3 point, reference point 1, turn vertex off because I want a reference point. 1, 2, 3, set view, front view. I just realized a mistake that I've made. Okay, and I guess normally I would project and orient it to the C-plane, but now we're going to orient it to the vertices on this transom. So let's see how this comes out. Okay, so that's worked. But now we need to rotate this. We want to bring this plumb. So, a plumb or straight up and down. Basically this bar and this bar want to be straight up and down. So I think we need to orient a C-plane on the angle of this transom. So before, when I rotated the transom, I shouldn't have done that. I should have left it. Oh, I suppose it's not too late actually. I might go back. Just to make 3D modeling easy, I'm going to rotate this, and actually no, I won't. No, I think we'll keep it where it is, which means that I need to set up a C-plane on here. So C-plane, 3 point, C-plane origin. Well, let's go, I don't know, somewhere close to here, and then this is going to be, oh, that was a mistake. Okay, we'll do it again. C-plane origin, C-plane 3 points, 1, and we want to be, we'll go front view, want to be, this is going to be the x-axis, we want to be probably here, and the y-axis there. There we go. And now if we type in plan, the planar to the C-plane. Now if we click on this and we change the gumball to align to C-plane, when we rotate it, it's going to rotate perfectly on the surface of the transom. So now how much do we need to rotate it to get it plumb? So I think what we'll do here is I think we'll grab this and we'll do a section. And I'll take a section through here. Oh no, take a section through here. Isolate that, go into front view. Okay, and what we'll do is draw a line here to here, drafting, get the angle from here to here, 21 degrees. Okay, that's how much we need to rotate this. So and now we have to be aligned to the C-plane, so I'm going to hit F7. Okay, we'll just realign our C-plane quickly. C-plane, 3 points, 1, 2, 3. Rotate this. That's aligned to the C-plane. And what was the number? Was it 27? Oh, so it's 21. Okay, minus 21. Okay, how does that look? Yeah, it looks about right. Okay, now we have the correct angles, and I'm just going to call my boat building associate because I'm not sure if that should be facing that way up or the other way up, to be honest. I have a feeling that it should be the other way up. Now in this instance, it's 180 degrees, right? 180. Yeah. Okay. And it looks like we've come afoul. When we turned 180 degrees, it looks as though we must have turned on the world reference plane rather than on the C-plane. So see, when we snapped back to front view, the world C-plane aligned with the front orthographic view, and therefore the rotation gumball no longer rotates it according to that. So what we really need to do there is save the C-plane. So we'll do it one more time. C-plane, 3.1, 2, 3. So now if we rotate this C-plane, 180. There we go. See, now it's still aligned with the transom. Okay, well I can tell that's not right. So I think we had it the right way before. That looks about right. Okay, so now we go, we're going to save our C-plane, aren't we? So let me... So we go to here and set C-plane, named C-planes, save as Transom. Okay, so now you can see it there, right? Okay, so now we have world front, and transom. Right, so now I don't have to redo that every time. So now I can go plan view, and okay, we can just move this around. Now what's happening here is the transom C-plane is slightly misaligned on its XY view, so it's tilting the, well, it makes the transom appear that it's tilted, although that's actually the XY plane that I'm using. So what I'm going to do is I'll go world front, transom. That's the transformation. So that's another thing to fix. Right. So this is getting close to the point now where I have it set up that I can go on site and discuss with the boat builder the client's requirements, because I've basically got I've got the basic elements here. I've got the transom pod that we're going to be replicating these angles, and I've got the transom aligned in 3D space. So I'm going to say that we're pretty much ready for phase 2. So I'll finish this video here. It's kind of a live stream, I guess, and we'll continue this project. I'm going to ask the client, the boat builder, if this is kind of the correct orientation, even though it doesn't matter because everything's relative of the scan. When we build the kit that creates the molding for the transom extension, we want that to be, well, I guess that doesn't matter either, but I'm kind of imagining we might have the kit come up against the back. Well, we'll see. We'll talk to the boat builder. Okay, so thank you for your attention, and I'll release part 2 as I do it, probably quite soon, because it's just a live stream, so it doesn't require much editing or anything. If you like this, please like and subscribe my channel, and I always say this, but I am slowly working towards creating a course on reverse engineering scan data. If I'm someone that you think you could learn something from, because if this video is anything to go by, I've still got a lot to learn, but I get there in the end, and I don't really have anyone else that I work with that does this, so I've had to develop my own techniques. So thank you for your attention, and see you on part 2 of whatever I call this video, which is going to be something like reverse engineering a boat transom. Thank you.